This is the 2018 AQA AS Further Maths paper, and we're looking at the vector question on the paper. So we are told of a situation where we've got a theme park with some zip wires, and we're told for each of two zip wires, we're told of the coordinates of 2 points on the wire. And part A asks us to use the model to find the shortest distance between the zip wires. So let's just draw a sketch of what it might be like. So we've got these two zip wires, let's call them line 1 and line 2, and we're asked to find the shortest distance between them. And the shortest distance between them, well, will be when the vector between them is perpendicular to both lines. And so the vector between the two lines is a generalized L2 minus L1. So in order to find out when they're perpendicular, what we'll need to do is we'll find an equation which is the scalar product of the vector between the lines with a direction vector of L1, and for that to be perpendicular, that scalar product will have to be 0, and similarly the vector between the two lines with a direction vector of L2, and the scalar product of those will have to be 0. So first of all, let's find the vector equations for line 1 and line 2. So line 1, so the difference between these is going to be just 0, 100 and minus 20. And if we use 0, 0, 0 as our position vector on the line, then that just equals, let's call it lambda as our constant, as a line 1. And so for line 2, let's take a position vector on the line, that'll do nicely. And then a constant times the difference between them. And so we can do minus 10 take away 10, 100 take away 0, and minus 5 take away 20. So now we've got the vector equation of each line, we can find the vector between the lines, the generalized vector. So it's going to be L2 take away L1. So for L2 we've got our 10, there's no constants to subtract on L1, so that's just 10 minus 20 mu, and there's 0 lambdas. So that's all in the x direction. In the y direction there's no constant, we've got 100 mu, and take away 100 lambda. Then in the z direction 20 minus 25 mu, and we're taking away minus 20 lambda. So that's the vector connecting the two lines. We want to find when's the scalar product of this with the direction vector of L1 equal to 0, and the same with the scalar product of this with the direction vector of L2. So first of all with L1, so we'll take the x direction first, times that 0, plus let's just check, is that right, is that 100 mu, comes on and that's times 100, times 100, and then the last one minus 20. So if we multiply these out, we and for it to be perpendicular it will have to be equal to 0. So this this term is 0. We've got 10,000 mu, take 10,000 lambda, and then minus 20 times 20, minus 20 times 25 mu, minus 20 times 20. So we can simplify this, put the mu's, got the lambdas, and 400. So there's one equation, and now we want to do the same but the dot product between the vector between the lines and L2. So so this time it's 10 minus 20 mu times minus 20, 100 mu minus 100 lambda times 100, and plus that's times minus 25. So again we'll multiply it out and simplify it, and for it to be perpendicular this will need to equal 0. 100 times 100. And so we can again simplify this. Got a constant term, got our mu's, and our lambdas. So now we've got two simultaneous equations with two unknowns. So at this stage it's acceptable to use your calculator to work out what your two unknowns are. And we find that mu equals minus 44 over 63 and lambda is 2/3. And so what this is saying is for those values of m and of mu and lambda, then the vector between the two lines is perpendicular to both, and therefore it's the shortest distance between them. So we can substitute those into our vector equation for the distance between them. And so line 2 minus line 1 equals, so that's 10 minus 20 times 63, and then it's 100 mu minus 100 lambda, and then in the z direction 25 times 63